Your frequency bar graph should look like this. A relative frequency bar graph is created the same way, only you use the relative frequency numbers you calculated in a previous slide. On the next slide, notice the decimals on the scale on the left side of the graph instead of the actual M&M count. This next example is comparing two sets of data. The following data represent the marital status in millions of U.S. residents 18 years of age or older in 1990 and 2006. This time we want to draw a side-by-side relative frequency bar graph of the data. First, you have to total each column and calculate the relative frequencies by dividing the number in the category by the total for that column. The relative frequency for never married in 1990 is 40.4, which you can read from the graph, divided by 181.9, which is what you get when you add up all of the responses in the 1990 column. That means that 22% of the U.S. population 18 years or older were never married in 1990. After you calculate all of those, this is the graph you get. Notice that in the lighter shade of blue we have 1990 next to 2006 data, which is in the darker shade. And you can compare them easily year by year. The never married, you can see that there were more never married in 2006 than in 1990. You can see the relative frequency of married people was greater in 1990 than 2006. There was a greater number widowed in 1990. There was a greater percentage divorced in 2006 than in 1990. Putting the relative frequencies side by side in a bar graph gives you a good visual comparison of the data at a glance. These must be relative frequencies to compare two data sets. Just because a number in a category goes up, it may not be an actual increase relative to the total population if everything else went up also. Using relative frequencies puts everything on an even playing field. So remember, if you're going to compare two different data sets, don't use frequencies, use relative frequencies. Now let's talk about pie charts. A pie chart is a circle divided into sectors, which you know as a pie slice. Each sector represents a category of data. The area of each sector is proportional to the frequency of the category. Correctly drawing a pie chart requires some knowledge of geometry. We aren't going to draw them because technology can do that with the click of a button. We will just interpret them. But you need to be aware that the area of the slice needs to be proportional to the relative frequency of the category. Even though we're going to use technology, we want to look at how we construct a pie chart. So we have the following data representing the marital frequency of U.S. residents 18 years or older in 2006, and we're going to draw a pie chart. To construct the pie chart, you again must use relative frequency or percents because that tells you what proportion or percent of the area of the circle to let each slice be. That way, when you glance at a pie chart, the size of the slices accurately reflects the differences in the proportion of data in a particular category. Usually in a pie chart, relative frequencies are reported as percents instead of decimals. Recall that a decimal can be changed to a percent by moving the decimal 2 places to the right. So here's the data, and this would be a pie chart that represents that data. Notice the smallest slice is 6%. It's approximately half of the 11% slice because 11% is just a little bit less than twice 6%. And the 58% slice is more than half the pie because 50% would be half, so 58% would be somewhat more than that. Now let's look at organizing quantitative data. So our objectives are to organize discrete data into tables, to construct histograms of discrete data, and we're going to learn what discrete data is in just a minute, Organize continuous data in tables. We'll also learn what continuous means. Then we'll construct histograms of continuous data, and we'll draw stem and leaf plots. And we also need to be able to identify the shape of a distribution of data. Quantitative data is simply data that can be represented by numbers. Notice it is related to the word quantity, which is a number representing how many of something you have. Qualitative or categorical data is data that represents a quality or characteristic of the objects being studied, such as candy color, eye color, hair color, and we looked at that with the color of our M&Ms in previous slides. There are two types of quantities or quantitative data. Discrete data is something that can be counted with whole numbers, like the M&Ms we worked with. So you can count things with just whole numbers. You have 5 of these, you have 8 of these, you have 10 of these. So that's discrete data. Continuous data is something that is measured and might come out to be a fraction. An example of continuous data would be height or weight. People don't just go from 4 feet to 5 feet without passing through a continuous scale of heights in between. The first step in summarizing quantitative data is to determine whether the data is discrete or continuous. If the data is discrete and there are relatively few different values of the data, the categories of data would be the observations, just as in qualitative data. If the data is discrete, but there are many different values of the variable, or if the data is continuous, the categories of data, called classes, must be created using intervals of numbers. Let's look at how we would organize discrete data in tables. This is exactly the same as we did with the M&Ms, which were qualitative data. The following data represent the number of available cars in a household based on a random sample of 50 households. Construct a frequency and relative frequency distribution. And note, you've got to have the frequency before you can do the relative frequency distribution, even though the relative frequency distribution is the one that we're really going to use. You can't construct it if you don't do the frequency first. So here's your data. So first tally the number in each category or class. Pause here to do the calculations. You can check yourself on the next slide.